I'm not going to go into this slide because it's patently obvious to everyone here. I'm just going to talk about the three applications very briefly of solar storage. Number one, the brief, essentially cloud, what I call cloud mitigation. When a cloud goes over, you have a sudden and dramatic drop off, and then a sudden dramatic drop on, or whatever, tune in of that. And to ease that, the drama of those changes requires only a little bit of energy storage, but very good power characteristics of the energy storage system. Peak shifting is what I'm using, and these terms mean different things to different people, but essentially what I'm talking about with peak shifting is utilizing storage to solve seasonal load issues. So, and the example I give here is the ice energy system that's being built in Southern California. And essentially they're storing ice at night and utilizing heat transfer fluid to do the air conditioning system during the day at the buildings where they install these things. So it's going to be a distributed network of ice storage systems. I can't remember the number of units, but altogether it's 72 megawatts. And essentially SCAPA, the Southern California Power Purchase Authority, looked at building a peaker, a natural gas peaker, and said we can do this for the same cost and solve the problem with energy storage without using any fuel. I'm sorry, they wouldn't use fuel, obviously, to charge batteries, but they're using it in a more efficient way. Now, I'm using the term load shifting for the third application, and this is kind of the dream, probably the impossible dream, of whenever power is cheap, you buy it, store it. Whenever it's expensive, you discharge the energy storage system. And the idea in the solar application of somehow taking solar electricity and using it at night, which frankly, I am of the opinion that probably will never happen. And if it does, we're talking many, many decades from now for that to be the way that we make our electricity. However, there are some cases where mass load shifting is done. Raccoon Mountain is over a gigawatt capacity pumped hydro plant that was built along with a nuclear power plant in Tennessee. And essentially, because nuclear, you can't turn it off at night, they're essentially taking the nighttime load, the nighttime generation from the nuke, storing it, and doubling their daytime capacity. So back to lithium ion. This is our projection for the costs of making lithium ion cells and packs. And if anybody has any specific questions about this chart, I'm glad to answer them. But roughly, we're looking at, on the cell level, we're looking at a drop from above $800 a kilowatt hour today, or last year, to as little as $400 by 2015. This is a little bit more aggressive than some of our other forecasting peers, but it's based on what I'm hearing in the marketplace, and very, very real price quotes today that are being given today. So essentially, you get down to that number, $400 or $500 a kilowatt hour, and you're able to do a lot of things. Definitely not large-scale load shifting, but you might be able to do a little bit of peak shifting, and you definitely can do solar smoothing at those price levels. I'm working on a research report now about repurposing electric vehicle batteries for grid storage, and just wanted to mention this, that it's another way of getting that price even lower. If you can reutilize those batteries after they come out of the cars. And I also I love doing reports about that subject matter, because it's going to be 8 years before the first Chevy Volt battery comes out of the car. So I can say whatever I want to about that. I remember what I said 8 years ago. It's an analyst's dream. All right, the last thing I wanted to talk about is, if anybody noticed in EarthToTech.com, your VITA-owned clean tech section, it's a news site about clean tech programs. There was a report that came out this morning by Katie Fehrenbacher about this project. And I wanted to just tell you what I know about it. So this is really the first widespread solar energy storage network of distributed solar energy storage systems. And it is, which is very significant. So it's Tesla, as you can see the T there, it's a Tesla branded battery pack, Tesla Motors, the car company, which is the owner of Tesla, or the majority shareholder of Tesla is also the majority shareholder, or owns some big portion of Solar City, which I'm sure many of you are familiar with. And they collaborated to create this battery pack. It's sold with the Solar City PV systems. And nobody knows about this until literally today. Well, not nobody, they knew about it, but it was not public. I found out about it about a few weeks ago. Some folks at PG&E that I work with let me know that there was something interesting was happening on applications for the SGIP funds. So for those of you that are not familiar with California SGIP, it's a Self-Generation Incentive Program. It's a subsidy system for distributed generation, not solar, other forms of distributed generation. Last year they changed the rules to allow energy storage systems to qualify for this subsidy. And this system it appears to be designed to meet the specifications of the SGIP subsidy, which means they get $2.50 a watt for every system they sell, or they get to reduce, thereby reducing the cost of that to the end consumer. They are currently not working with any utilities on this. They're selling it to end consumers of the Solar City PV system. It is probably, and I'm getting a mix, they won't speak to me about it, at least not yet, but I'm getting a mix of information from various people who know a little bit about it. So I'm going to tell you what I know and what I'm guessing. And here I'm guessing it's probably $40,000 for a 20 kilowatt hour system, meaning $2,000 a kilowatt, which is very expensive and economically impossible to justify. However, if they are claiming the solar ITC for this, which is a legal possibility, although I don't think anyone has successfully done it yet, they get 30% off. Then they get the what I figured would be 62 cents a kilowatt hour off for the SGIP fund, which ends up being about 80 cents a watt hour for this system. Even with, and I have the wrong rate up here, wherever. It's not E19, it's E6. For in the third bullet point down there about the PG&E E19, it's E6. But which is the homeowner residential time of use rate. If you're using E6 and you're using the system to arbitrage your time of use rate, your residential time of use rate, you probably can spend about 50 cents a watt hour and make this the economic justification for the system. So it's still above the ROI threshold, or the net present value threshold. However, the people who are buying this are getting a very important service, which is reserve power. And what they're doing, what they appear to be doing, based on what they say on their website about this, is rewiring the home and doing critical circuits in the home, so that you have a base number of circuits that are wired to the system, so that if the grid goes down, it feeds off the battery pack for those however many hours your system is designed for. So it's essentially a way of using batteries to do reserve power for critical systems. So that's what I know about this. It's a very interesting concept. It's very interesting also that they're doing it directly to the homeowners, not selling it through utilities, which is how every other community energy storage or building energy storage system has been done. And it's also interesting because they have 70 projects in process, that we know of, and possibly as many as 200 in California. It doesn't make sense anywhere else because of the subsidies in California. And that is my presentation. Anybody who has questions?